Okay, so really what we're going to be doing is three different versions of the same thing. Kind of like we did transformational form, slope-intercept form, there's standard form. There's lots of different formats for your answers for graphing straight lines, right? Well, there's going to be different formats for writing your domain and range. So look at them as equals, and later on, well, actually pretty quickly, you'll see that you can convert from one to the other just depending on the problem. And there's different reasons why there's three different ways of writing domain and range. They all mean the exact same thing, but we use them differently just throughout Algebra 2, pre-calculus, calculus. They just use different versions of it, so that's why we're getting familiar with all of them. But your main goal for today is being able to look at a graph, like say number 1 here, and pinpoint, does the graph go on forever in every direction for both x and y? Or does it seem to start at a particular place and then keep going? Okay. So first of all, let's look at something that's, I don't know, maybe pretty clear and apparent on here, is that this graph, number 1, clearly has a starting point right here, right? Like it doesn't go up at all. It just starts here and goes straight down. So it starts at y equals 3, right, on the y-axis, and then it goes down, right? From here, then it goes down. How far does this go down? Yeah, to infinite. So really it starts at 3, and then it goes down forever, and really since it's going down, it's going to be negative infinity. So just wrap your head around that for a second, that this starts at 3 and goes down to negative infinity. But it definitely has a starting point. Now, as you saw when you guys were doing it on Desmos, you have to put the smaller number first. So we'd really say this goes from negative infinity to 3. It means the same thing, but we always put the smaller number first. Okay. So for the range here, we're actually going to go from negative infinity. You got to get good at writing this symbol. Negative infinity, and just like on Desmos, less than y, and it's going to stop at positive 3. So that will be the range, just because it stops there. Now there's different ways of writing it. And luckily the next version of it, which we call set notation, right? Set notation is very similar to what you're going to write here, which is called inequality. This is the inequality right here. And then set notation is just another way of writing it. It uses these curly braces, and we put something in front of it. We put y, and then a vertical line that means such that. Right? And then we put this thing in its entirety in here. So the set notation and inequality are almost one and the same, but the set notation includes a little bit more. Simply because when you start doing things in multivariables, you need to declare at the very beginning what variable are we looking at, because we can have more than just y and more than just x. So we have this one little part here that's a little different because of that. But for you guys in Algebra 2, it's not going to seem like it's different at all. So just know that they are one and the same. If you know one, you know the other. Okay. The other one that we're going to use is called the set notation, or interval notation, is going to be without all the fancy inequalities, the y's and all that good stuff, and you just put it in parentheses like this. For anything that is just less than, you use a parenthesis, right? Anything that's less than or equal to, let's do black, less than or equal to, you're going to use a bracket. So since this is 3, we're going to use 3 and then this bracket. So with the equal to, it's a bracket. Without an equal to, it's a parenthesis. And this is like a really short form that we use in programming, and graphing calculators use this because it's just faster and easier to put in. You imagine on Desmos, if you didn't have to put all these inequalities in, and you just had to put this in, it would make a lot more sense. It would be a lot faster. So this is more of a convenience one right here. That's called interval notation. Now, this is going to be a small but important detail for vocab reasons. For those of you that do a lot of vocab and you take notes, this is one of those things you really want to take notes for, because on the directions it could ask for interval notation, but it could also ask for set notation, and you have to write it down in the proper way. So those are the 3 proper ways of writing all of them. 2 of them being very similar, the third being different with some details. Again, we use parentheses because it's less than. We use the bracket here because it's less than or equal to. That's why we use those. So you can have 2 parentheses, you could have both brackets. Just depends on the inequality that you would have right here. Infinity is never equal to. Infinity is this weird thing that you can never actually get to infinity. Like, you can't count infinity. Because no matter what number you come up with, there's another number that's bigger than that, or there's another number smaller than that. And no matter what 2 numbers you can think of, there's always another number between those 2 numbers. So there's never actually a way of arriving at infinity or getting to infinity. It's always something that's just one more number away from you, no matter what you do. And then once you get into calculus, there's a whole thing about this, like, well, what do you do when you need to divide by infinity? You know, and that's what calculus is largely made up of. They come across these problems that we have these infinite issues. And how do we handle that? That's where calculus comes in. So this is like the beginning groundwork for all of that. Just figuring out what is infinity. Okay, so now we did the range. Let's look at, how about number 3? That's kind of similar. So this one started at 3 and went down to negative infinity. So we wrote it as negative infinity, less than y, less than or equal to 3. Where does this one start? On number 3, where does the range start? 1, yeah, right. So right here. So instead of starting at 3, it starts at 1. And it goes to negative infinity. So in the same way, we'll write negative infinity, less than, never equal to with infinity. We're using the y-axis, right? That's why I'm kind of circling right here, because you know that this 1 is the y-axis. So that's why I know it's a range. And it should belong here. Y's are always going to be the range. And then it's going to go to 1. Always a smaller number first, so if you're using negative infinity, that's always going to be the first thing written. And we can write that in the set notation, which is simply just the y, and this line here is such that the variable y is such that negative infinity is between y is between negative infinity and positive 1. Right? And then for the interval notation, we use parentheses, always use parentheses for infinity, from negative infinity to positive 1. Since it's equal to, it does actually equal positive 1, so I want to use an equal to here, as well as here, which makes this a bracket. So when there's a clear number where the graph starts and stops, it makes it a little bit easier. Okay? It's when you get to something like number 2 and you're looking at this that, well, it seems to go down. This is going to go down forever, right? That's not going to stop. We know the range is going to start at negative infinity. The question is, does it stop anywhere when you go up? Does this graph ever stop moving upwards? No, it keeps on going. See, it's going up, it's going up, it's going up, it's going up even less, but it's still going up ever so slightly. But if this kept on going forever, which is what this arrow means, it keeps going forever, it's going to keep slightly going up forever. So this is actually going to go from negative infinity to positive infinity. It's going to keep on going, and it's not going to stop. So there's no clear stopping point like we had here and here, where clearly it's going up and then it makes a turn and goes back down. Same thing here, it's going up, makes a turn and goes back down. This one just keeps on going no matter what. So for those, another way of saying this would be all real numbers, from everything from negative infinity to positive infinity. Well, that's every number, right? So we just write it this way. And then same thing, the range is going to be y such that y is between negative infinity and positive infinity. And the interval would be both parentheses, because infinity is always parentheses no matter what. You can't actually get to infinity. And it'll be negative infinity here, comma, and then infinity. You don't need to put a plus sign on the positive one. It's assumed as positive, regular numbers. Yeah, why? How come there's no bracket? Yeah, so two things. Infinity never has a bracket because it's never equal to. So because this has an equal to, that's why it had a bracket. Same thing here, this had an equal to. So this has a bracket, but these, you can never actually be equal to infinity. So you can't have a bracket. So these details are the things that you'll be graded on very closely, by the way, is that when you have infinity, did you just use less thans and not less thans or equal tos and things like that? Those are the small details. Close it up. Very good. Yeah, let's close that up. Yeah, so we got brackets that are the square ones. That's a bracket. The curly ones are braces, and then you know what parentheses are. So those are the three types of grouping symbols that we have: parentheses, braces, and brackets. All right, good. So let's see here. Let's go. Let's just stick with range and go down. I'll give you a second. See what you come up with, and just do the first part for each of them. And then we'll correct it if it needs to be corrected, and then we can write the other two versions. But let's first make sure we got the concept down on, do you see the graph kind of stopping anywhere, or does it keep going in some direction? And let's look at just the y value. So we saw that this starts at 0. Now, it's kind of hard to tell if this actually equals 0 or not, so you could use a less than or less than or equal to. It's kind of hard to tell by looking at this graph. But it definitely keeps on going up forever to positive infinity. So again, it's debatable whether this would be equal to or not, because by looking at the graph, you can't really tell, so either one would be acceptable. Whereas the range here, the dots clearly indicate that's an answer. So it's clearly going to be -4 is a solution. That's part of the range, so we definitely have to have an equal to on both of these. That's what the closed dots represent. If these were open dots, these would not be equal tos. These would just be strictly less than. Yep, they both have dots, so they are definitely equal to. The dots mean equal to. So we had open dots, closed dots when you're graphing inequalities. This is part of that. So both sides have the brackets, for sure. Both sides have brackets. They're both equal to. And I know this because of the closed dots. What about here? Where does it go from between? Yeah, -1 and +1. And just like the parabola that we did up above, these are like definitely hits this point, so it's going to be equal to. So -1, +1. There we go. Because of the yeah. Here it doesn't have the closed dots, but we can visually see it turns around right at this point. And I'm leaving you to do the middle one here on your own. And now that we have range down, can we do the same thing, but left and right, ignoring the vertical and only doing horizontal, looking at the domain only? So forget these numbers now. We're not going to use any of these numbers when you're looking at domain. if you can describe this graph only using the horizontal here, the x, domain is always x, right? How would you describe each of these graphs? Do any of them ever stop if you keep going left or keep going right? So will this graph ever stop at some point if you go left? It will ever stop if you keep going right? No. So what does that mean? Yeah. Negative infinity to positive infinity. It never stops if you go left or right at all. I've seen people do this, what I just did, where they actually cross off the numbers because they get confused about which ones you use for which. So just know that domain is always x. If you want to like go over the y values when you're trying to do domain, so you only use these numbers and think about those numbers, it does help. Having two sets of numbers sometimes mixes you up. You're not sure which one you're using. So just be very focused at that point. One of the most common mistakes is just having these both correct, but in the wrong place. You're saying that this is the range and this is a domain. So just be very careful. The details do matter. So there's a lot of small things going on. You can tell this is not about, Algebra 2 is kind of less about add this to both sides, subtract this to both sides, get the answer, x equals this. It's more, critical thinking and looking at the graph a certain way. What about number 2? If you go left or right, does it ever stop in a certain direction? So if I keep on going left, does this graph actually stop going left at some point? Yeah, you can see right here, it starts shooting straight down. It never actually gets from this point and to the left, it never keeps on going. It got to this point and it just started going down and never turned. So what number would this be? You remember, you're not using these numbers, using all these numbers. What number would this be right here? At 0. Again, it's up for debate whether this actually gets to 0 or if it's equal to 0 at some point. But if we don't know, let's just not say it's equal to. So I'll leave it open. What about if I go right? Does this graph ever stop going right? Nope. So that goes to positive infinity forever. So this will go 7, 8, 9, 10. It's going to go forever. It has the arrow on it, so that's how I know it keeps on going. If it had a dot on the end, I know it stops. So we're going to go 0 to infinity, both parentheses. What about the last one, number 3? Does it ever stop going left or right? No, it keeps on going left forever. I mean, it's going down, but it's also slightly going to the left as well. It's going down more than left, but it keeps on going left or right. So this is another all real numbers, which is negative infinity to positive infinity. At some point, you might see this written a fancy way when it's all reals or negative infinity to positive infinity. It uses R. It's an R like this, but it has like another vertical line there. And that means all reals, which is the same thing as negative infinity to positive infinity. So all numbers. So another way of, you might see this symbol at some point in the book when we get them, and different ways of saying the same thing. This is really used in proofs more, this R. Instead of writing out domain like this, they just put all the domain arranges all real numbers. It's R. They use that symbol. So it's just a shorthand. Okay. So hopefully that gives you a good concept of domain and range from doing this with where they start and stop. And then adding in on the back the idea of infinity, that if it doesn't actually physically see it stopping at a number, then we just put infinity because it goes on forever. Infinity never has an equal to on it, so infinity will always be a parenthesis in these different notations. So parentheses are more common in interval notation when you're dealing with graphs, because infinity is usually on one or both of the domain or range. All right, good. So let's look at